Namaste everyone, hope all of you are well. This is a shortcut revision of class 11 chapter number 12 organic chemistry, basic concepts of organic chemistry. This is a shortcut revision of each and every topic. Don't skip the video for a second also, otherwise you will miss the things which are important. So let's start. First of all, organic chemistry was started with the vital force theory. Vital force theory was specially introduced that none of the organic compounds can be formed in laboratory, right? So after then, the main scientist called Euler has introduced that there are possibilities to form organic compounds in lab. That was urea. Urea was the first organic compound which was formed in laboratory. After that, so many compounds have came like formic acid, acetic acid, alcohol, and many of the organic compounds have come. Organic compounds means this compound which are obtained from plants and animals, right? And it can be synthesized in laboratory. After that, Iopsc Nomenclature had came. Then we have divided the organic compounds into the two parts. First of all, you should know that what are those two parts which are being divided. Means, first of all, if I talk about the hydrocarbons, hydrocarbons has been divided into the two parts, right? Can you tell me what are the two parts? I hope that you know very well. Acyclic and cyclic, right? Acyclic hydrocarbons and cyclic hydrocarbons. This acyclic hydrocarbons has been also divided into the two parts, that is saturated hydrocarbons and unsaturated hydrocarbons. You know very well what is this unsaturated and saturated hydrocarbons. I hope in the junior standards you may have studied about these all the things. Saturated hydrocarbons are carbon with a straight chain having single bonds, and unsaturated double bond and triple bonds. You can say this as alkene and alkynes, right? Alkenes and alkynes. And here this is a saturated means alkanes which are in single bonds, right? And in the cyclic it has been also divided into the two parts. Now you can say, sir, what are the two parts? I hope that you know very well. You can say it is a cyclic means closed chain or a ring chain. Closed chain or a ring chain. Cyclic is also known as ring chain or a closed chain compounds, right? So these are divided into the two parts, homo and heterocyclic ring chains. You know very well what is homocyclic and heterocyclic. Homocyclic has been divided into the further 2-3 parts, but heterocyclic is just a heterocyclic organic compounds, and homocyclic, this is homocyclic has been divided into also 2 and 3 parts. I hope that you know very well this homocyclic organic compounds. You can say it is a alicyclic or aromatic. Homocyclic ring compounds has been divided into 2 parts. Can you tell me the 2 parts name? That is aromatic and alicyclic. You know very well what is alicyclic and aromatic. Alicyclic and aromatic, right? So first of all, go through this topic: hydrocarbons, acyclic hydrocarbons, cyclic hydrocarbons, acyclic, saturated, unsaturated, and cyclic or closed chain, you can say ring chain, have been divided into the 2 parts, heterocyclic and homocyclic. Homocyclic has been also divided into the 2 parts, alicyclic and aromatic. Alicyclic, saturated and unsaturated. Saturated and unsaturated means here, see, it is also divided into the 2 parts, saturated and unsaturated means saturated alicyclic compounds and unsaturated alicyclic compounds. Now you will tell me, sir, what is this saturated and unsaturated? These are just, you can say, cyclo means aromatic, saturated means alkanes, cycloalkanes. It will be no double bond, no triple bond. It is only cycloalkanes. And in unsaturated it will be cycloalkenes and cycloalkynes. Cycloalkenes and cycloalkynes. And if I talk about the aromatic, right? Now here there are also 3 parts of this aromatic homocyclic ring chain of hydrocarbons. What are this? Benzenoid, non-benzenoid, and one is heterocyclic, that one is another. So here aromatic you can directly divide into the two parts, benzenoid and non-benzenoid. Benzenoid and second one is non-benzenoid. You can say these are the furane, and here benzenoid you can say like benzene, anthracene, naphthalene, you can see like that compounds, right? So these are benzenoid compounds. So these are the special distribution of hydrocarbons. Acyclic, cyclics, acyclic divided into the saturated hydrocarbons, unsaturated hydrocarbons, cyclic divided into the heterocyclic, homocyclic, alicyclic and aromatic, alicyclic into the saturated and unsaturated, aromatic into the benzenoid and non-benzenoid, and last one was heterocyclic. You may have heard this heterocyclic compound. So the heterocyclic means just non-benzenoids, after that this heterocyclic compound comes, which is in the form of, so you can say like more than 6 carbons, 7 carbon, 8 carbons in the bond, forms double bond, triple bond. So this was a short form, or you can say a flowchart diagrams of hydrocarbon. In this way the hydrocarbons can exist. Now you know very well a homologous series. Homologous series is the difference between the two carbons is CH2. This is called homologous series. Why carbon is having this property? Because carbon can attach with its own element. Means carbon, double bond, triple bond, single bond. You can see these two different carbons. The next topic is about the Iopsc nomenclature. First of all, take a screenshot that you will be able to understand that how many types of saturated and unsaturated hydrocarbons are there. I am zooming it. Please take a screenshot. Hope all of you have taken the screenshot. Now let's move ahead. Our next topic is related to Iopsc nomenclature. The things which we have studied in the junior standards of Iopsc nomenclature, a little bit different here. What is Iopsc nomenclature? Especially for it was introduced for, as we have right now on acyclic and cyclic. In the 10th standard you may have heard about acyclic, saturated and unsaturated hydrocarbons. But in 11th standard you will go through especially for the cyclic also. In the cyclic also we have divided into the two parts, aromatic, alicyclic. After that in the aromatic also benzenoid, non-benzenoid, directly saturated or cyclic, and alicyclic and unsaturated alicyclic. So these are all the names how you will write. So first of all you should know that which things are specially introduced in this Iopsc nomenclature. The things which are introduced is words root. Words root means the number of carbon. You know very well C1 to C30, right? C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C20 and C30. Can you tell me what is these all words root? These are the number of carbons: meth, eth, prop, but, pent, hex, hept, oct, non, dec. And after 11, 12 you can introduce as a undec and dudec, tridec. So 11, 12 till 13, 14, 15, 16, 17, 18, 19 you can go undec and dudec. If I talk about 20 and 30, the number of words root of carbon, if you want to know the names of this 20 and 30, that is called icosane and tricontane. Icosane and tricontane. So this is the words root of carbon, right? Now linkage. Linkage means single bond, double bond, triple bond. that is ane, suffix ene and yne. Right? Now come to the form of primary and secondary suffix. Primary and secondary suffix. This is very, very important part of this Iopsc nomenclature. Primary and secondary. How you will introduce as a primary and secondary, especially for the nomenclature topic, that primary suffix and secondary suffix. It is also known as principal functional group. Principal functional group: carboxylic acid, sulfonic acid, acetic acid, carboxylic acid, acetyl chloride, ammonic acid, cyanide, aldehyde, ketone, alcohol, ammonia, ethene, ethyne. These are especially principal functional group, that is called, especially you can say that seniority table. Here primary and secondary, it is especially used for prefix and suffix. Prefix and suffix. Generally suffix is also two types, primary and secondary suffix, but here you have to understand, in the prefix you can say that we use especially for the linkage. All the linkage means, you know, here single bond, double bond, triple bond, and also especially for halogens. Okay? And if two functional groups are given, then you can distribute as in the form of suffix also, primary suffix and secondary suffix. When you will write the nomenclature, that time you have to give priority the functional group which is containing with the carbon, means carbon containing functional group. You have to give priority carbon containing functional group. Just suppose that if alcohol and aldehyde both are given, just I am giving you an example. Here just suppose 3. Here you can say this is a aldehyde group, and here I am giving you alcohol group. So if I will ask you what will be the name of this compound, if anybody will ask you what will be the name of this, so here you have to make the parent chain with this. Here you will start counting 1, 2, 3, 2-hydroxy, 2-hydroxy propanol or propan 1 earth. So this will be the Iopsc name of this compound. So whenever, why I am showing you carbon containing functional group, you have to give priority, and rest whatever the suffix functional groups are there just means alcohol, aldehydes, ketones. Ketone is a carbon containing functional group. Aldehydes is also a carbon containing. After that you can say carboxylic acids. So these are carbon containing, and rest of that you can just as a secondary suffix you can mention, as you can see here where I have mentioned this hydroxy. Similarly you can go through these all the things and you can write Iopsc nomenclature. It's not too hard to understand the concept of Iopsc nomenclature. It is just need of practice. As you practice more and more compounds, you will get all the names of this Iopsc, and it's very easy to write. Now we'll talk about the isomerism. Isomerism means what? I hope that all of you know about the isomerism. First of all, take a screenshot of this board. I hope it is visible to everyone. Right? Yeah. Now we are moving towards isomerism. Can anybody tell me what is isomerism or isomers? Molecular formula same but structural formula different are called isomers, and this phenomenon is known as isomerism. You may have heard in junior standard till 10th standard, you may have heard that chemical or molecular formula is same but structural formula is different. That is called isomers, or you can say this phenomenon is isomerism. So isomerism is nothing when the molecular formula same. Just remember, molecular formula will be the same always. Molecular formula same, structural formula different. What do you understand by molecular and structural formula? Here there will be different. Now this phenomenon is known as right? This phenomenon is known as isomerism. Right? So this phenomenon is called isomerism. If I talk about the types of isomerism, there are generally two types of isomerism. In the junior standard you may have heard about that neopentane, isopentane and normal pentane. Especially isomerism has been divided into the two parts. The two parts are structural isomerism and stereoisomerism. Structural and stereo. Now you will ask me, sir, what is this structural and stereoisomerism? The things which we study about that molecular formula, same structural formula different. This comes in structural isomerism. This structural isomerism has been divided into the 5 parts. How many parts? 5 parts. Now you will tell me, sir, what are the 5 parts? Sir, please name that 5 parts of that structural isomerism. Chain isomerism. Normal iso-neo. Just pentane if I talk about. Normal pentane, isopentane and neopentane. These are the examples of chain structural isomerism. Now second thing is positional isomerism. What do you understand by positional isomerism? Have you ever gone through the positional isomerism? Anyone? I hope you have gone through the positional isomerism. In the positional isomerism, what happened? The positions of the functional group changes. Positional isomerism, 2-propanol. Means you understand that on the second position alcohol is there. Otherwise propanol. At the first position here propanol is there. So position changes. Third one is functional structural isomerism. In aldehyde, just suppose here aldehyde group is there and ketone group is there. What will be the changes? Can you tell me? In the aldehyde and ketone group, there will be a difference. Now, molecular formula will be the same. If I talk about propanone and propanol, right? Since propanone means 2-propanol and propanol means 1-propanol. So here there is aldehyde and here it is a ketone. The functional group changes. Molecular formula are same, but the functional group is changed. That type of isomerism is called structural isomerism. Now next one, if I talk about, that is metamerism. What do you understand by metamerism? Can anyone tell me? Metamerism means that when the different functional group molecules are exchanged. Means here the molecular formula will be the same, but the compounds will be changed. Means if I talk about ether, just suppose here in the metamerism, CH3O C3H7, methoxypropane. And if I talk about C2H5O C2H5, ethoxyethane. You can see the molecular formula is same, but the name of the compound will be changed. That is called metamerism. The last is tautomerism. This arises due to the migration of hydrogen atom from one polyvalent atom to the another polyvalent atom with the same molecular with the necessary rearrangement of linkage. Tautomerism is especially for hydrogen atom. Means double bond and triple bond. You can see the molecular formula will be same. Here, just suppose this 3 carbon is there. On the second carbon, there is a double bond. Or you can say here on the first carbon there is a double bond. Or you can say here, if I talk about the second position here, and if the hydrogen atom is changing, and here on this third position, this double bond has came. So this type of phenomenon comes in structural isomerism. Stereoisomerism has been divided into the 2 parts, geometrical isomerism and optical isomerism. Geometrical and optical. In the geometrical isomerism, if I talk about the geometrical isomerism, they are also of 2 types, that is cis and trans. Cis isomerism and trans isomerism. But if I talk about optical, in the optical isomerism there will be a dextro and levo, that image form, dextro and levo. Okay, so these are the types of isomerism. You can go through it, you can do the practice of this isomerism, more and more isomerism, you will get all the names of this isomerism. Now the next topic is about the reaction mechanism of intermediates of the carbon atom. Just have a look and take a screenshot. That will be beneficial. No need to write, just to listen the compound's name and understanding nature. Yeah, now we can move ahead. I hope all of you have taken the screenshot. Now I'm moving ahead on the next topic, that is fundamental concept of organic reaction mechanism. So first of all, I would like to tell you about the heterolytic cleavage and homolytic cleavage in the reaction mechanism introduction. What is reaction mechanism? Reaction mechanism means when an organic compound reacts with another compounds, wherever, if just suppose any organic compound is there, okay, in that organic compounds, wherever that carbon is going to do reaction, that compound, that part we call as a substrate, and the element which is doing reaction with this organic compound, that reactant will known as reagent. What is it known as? Reagent. So this reagent attacks on substrate and you get a new product because of the replacement of the hydrogen atom. That's called product. So now here, this mechanism, reaction mechanism, in this reaction mechanism, there are in the organic compounds, you know very well, there is covalent compound. Yes, in this organic, there is covalent compound, and cleavage means breaking down of bonds. There are two types of cleavage: homolytic cleavage and heterolytic cleavage. You know very well what is homolytic and heterolytic. Homo means same atom. When the two same atoms, just suppose Cl2 chlorine, same electronegative value. When this chlorine breaks down into the Cl2 minus ion, so that will be known as homolytic. And heterolytic cleavage atom, in the heterolytic, just suppose here methyl chloride is there, CH3Cl, right? In the methyl chloride, chlorine is highly electronegative element in comparison to this methyl group. So this bond, which is formed by the two electrons, this bond will be shifted towards the chlorine. This bond will break down as in the form of CH3 plus. Here there is a lack of electron on the carbon atom, and chlorine will gain this bond and it will be charged as a negative ion. So this type of breaking down of bond, or you can say bond cleavage, is known as heterolytic bond cleavage, and homolytic bond cleavage involves the breaking of covalent bond, such a fusion that of the electrons of the shared pair goes with each of the bonded atom with the formation of free radicals. Free radicals. Yeah, in the homolytic you can understand just suppose that sodium chloride is an ionic compound. You know very well here sodium plus and chloride minus, free radicals, cation, free radicals, and ion. But in the form of here you can see both the sides, this half electron and half electron are shifted, so Cl minus. So this type of bond cleavage is known as homolytic bond cleavage. Yes, I hope you have understand about the homolytic and heterolytic bond cleavage. So go through this homolytic and heterolytic bond cleavage atom. Now we'll move ahead. Now the next type of reaction, intermediate, hybridization, stability orders. If you move towards carbocation, sp2 hybridization, tertiary is greater than secondary, is greater than primary. If I talk about carbon anion, in that primary is greater than secondary, is greater than tertiary. And if I talk about the free radicals, tertiary greater than secondary, greater than primary. Attacking reagent, nucleophilic and electrophilics. So here as I have shown you that, what do you understand by electrophilic and nucleophilic? Wherever the electron goes and reach, or you can say any compound which is having lone pair of electrons, where it is a highly electronegative element, the bond can be shifted towards that will be known as nucleophilic, and from wherever the electron has been removed, that part will be known as electrophilic. Okay, now let's move towards the covalent compounds as an inductive, electromagnetic and resonance effect. Why this type of effects happen? Because there is a displacement of electrons in covalent bonds. Displacement of electrons arises this type of effects that are inductive effect, resonance effect, electromagnetic effect and hyperconjugation. So first of all, let me say you what is inductive effect. When sigma electrons arises a bond polarity, just suppose that propyl chloride, this is a propyl chloride chemical formula. Here chlorine is highly electronegative and here sigma bond formation, chlorine has 3 lone pair electrons. The electron clouds will be towards the chlorine, right? Now if I just talk about the polarizations of bond, this polarizations of chlorine arises, or you can say induces an effect. That effect is called inductive effect. So here in this propyl chloride, if you just suppose that if you are breaking this bond, then here propyl will be known as here electron deficient compound, and here chlorine has gained 1 electron, it will be electron rich compound. It is already having 3 lone pair and 1 negative charge on it. So here this breaking down as breaks into delta minus and delta plus. Because of this delta plus, would you think that as the sigma bond has break, so there will be effect on this intervening bonds of carbon? So here there will be intervening effects of delta plus, delta minus. So this type of effect is called inductive effect. There are 2 types of inductive effect: positive inductive effect and negative inductive effect. Positive inductive effect, as you know very well, if I talk about positive inductive effect, that are called ethyl, so all the alkyl groups, right? All the alkyl groups decrease, you can say that propyl, ethyl, methyl, these all are the plus I effect and minus I effect, nitro, cyano, carboxylic acid, fluoro, chloro, bromo, hydro and hydrogen. These all are negative inductive effect. Now next one is electromagnetic effect. Electromagnetic effect, especially it involves the transfer of pi electrons from the multiple bonds from one bonded atoms to the another bonded atom because of the attacking reagent. So there are also 2 types: plus effect, with the electron transfer take place towards the atom which the attacking reagent gets attached, and minus effect, when the electron transfer take place from the atom to the attacking reagent gets attached. This was electromagnetic effect. In the electromagnetic effect, just suppose here that ethyl bond is there, ethene, okay? So in this ethene, this double bond shift, where this double bond is, because here there is a lack of electron carbon atom, so this double bond will be shifted here, and here just suppose if hydrogen atom is there, this hydrogen atom will be attached by here. So here there will be only 3 carbons bond link, and here there will be 4. So this carbon will have a lac atoms and this carbon will complete its octet. So this type of effect is called electromagnetic effect, positive and negative. I hope you understand. Now the resonance effect. Resonance effect is also arises due to the pi bond and lone pair of electrons. Just suppose if I talk about the resonance effect, in the resonance effect, the electrons of pi bond, have you heard about the aniline compound's name? I hope you may have heard aniline, NH2. And here the nitrogen has a lone pair of electrons. So what will happen, you know? Here this lone pair electron will be shifted here, as it will shift here. This pi bond will shift to this carbon. So what will happen here, you know? I hope you know. This is a benzene. In this benzene, nitrogen will get double bond. Here there will be a lack of electrons, and this pi bond is shifted to this here, and there is this 2 electrons. So this lone pair of electron will shift on this carbon atom, and this carbon atom will get the lone pair electron, because carbon can maximum contain here 4 bonds. So here you can see the next structure will be like this. Now what will happen? This will shift here and this will go to this bond. So here the next structure, as you can see here, and H2. Everywhere you have to put positive charge on nitrogen. Now this finally it will go to this, and this pi bond will shift to lone pair of nitrogen, and this will be the final structure of nitrogen NH2 lone pair electron. As you can see, this is the resonance structure of aniline, and this is also known as plus R effect, lack of electrons. And second one is nitro, minus R effect. So what will happen here? You know very well there is a 2 lone pair on oxygen, 1 lone pair on nitrogen. If this bond shift is here, what will happen? Now this oxygen will get triple bond. As this bond will shift here, you will get a positive charge, right? So in the second step, you know very well what will happen. Here you will get a positive charge, there will be lack of electrons. Here nitrogen will get double bond, oxygen will get 3 lone pair and a negative charge on it, and here this. So here this bond has shifted and here. Now what will happen in the second? This pi bond will shift to here wherever the lack of electron is there. So here this pi bond will shift here, and in this carbon atom there will be a lack of electrons, right? So here there will be a lack of electron. This pi bond has shifted to this one, and now here there is a double bond of nitrogen. So here this structure you will get it. Now the next step, this one will shift here, and here there will be a lack of electrons. Negative charge on it, right? And here now the final structure, what will happen? This pi bond will come here, it will fulfill this carbon atom's octet, and the structure will be known as like this. Here nitrogen will get single bond because this here it is going to shift electrons, and here the single bond oxygen and double bond oxygen. Here this structure is known as minus R effect. This is minus R effect, and this is plus R effect. So these are the resonance effect. I hope all of you understand. Now next we are moving towards the hyperconjugation. It involves delocalizations of sigma electrons of carbon-hydrogen bond of an alkyl group directly attached to an atom to unsaturated system with an atom of a saturated. Unsaturated to saturated, you know very well, as I have shown you in the hyperconjugation, that how an unsaturated carbonic compounds involved with the saturated hydrocarbons in the form of hyperconjugation. Now we will talk about the methods of purification of organic compounds. There are two types of purification methods. One is analytical. In the analytical, volumetric, and especially if I talk about these two types of the separations or purifications of organic compounds are volumetric, and second one is analytical. Methods of purification of organic compounds, it depends upon the methods by which you are separating. These two types of methods are known as qualitative and quantitative. Here first of all you have to detect the organic compounds by the methods, that what are the methods by which you can separate the organic compounds. The first methods to separate the organic compounds is called sublimation, second called crystallization, distillation. There are two types of distillation, simple distillation and fractional distillation, and last one is chromatography. There are two types of chromatography also, adsorption chromatography and thin layer chromatography. So these are the types of separating organic pure compounds. Now I'll not take your more time, just I'll directly come towards the main topic, that is qualitative and quantitative. So I hope that purification of organic compounds you have known as purification of organic compounds, right, through the methods of crystallization. Sorry, first of all, sublimation. Can you tell me what is sublimation? Sublimation is a process by which solid directly converts into the vapor state without going into the liquid state. That's called sublimation. Sublimation is a process in which the solid directly converts into the into the gaseous state without going into the liquid state. That's called sublimation. As for example, separations of naphthalene or iodine from the naphthalene, that's sublimation. Second is crystallization. Crystallization process is specially used for the volatile and non-volatile, as the sugar crystals or salt crystals formation, crystallization. Third one is distillation. Distillation is of two types, simple distillations and fractional distillation. Simple distillation, in which both the volatile liquids will have the high difference of boiling points, that will be separated through the simple distillation, and which will have low boiling point difference will be separated through the fractional distillation, as for example crude oils. Now if I talk about the last one was chromatography. This chromatography means colorful organic compound separations, purifications. It can be done by two methods, adsorptions and thin layer separation method. So these are the purification methods of organic compounds. Now directly coming towards the qualitative and quantitative. Qualitative organic compound separations, and second one is quantitative organic compound separation. Quantitative organic compound separation. In the qualitative, you have to detect that which organic compound is present in this. Organic compounds, generally you understand that it is made up of carbons, right? When any organic compounds which are having carbon, and that carbon will react with cuprous oxide, will be heated, then you know very well copper dioxide gas will release, and that copper dioxide will give you the confirmation that this is an organic compound which contains carbon. Second one is hydrogen one. If this cuprous oxide reacts with hydrogen, this cuprous oxide, if it reacts with hydrogen, what will happen? You know very well, copper will be separated and water you will get it, right? So these two methods, especially it is known as the conformation of hydrogen and conformation of carbon. Now next one is nitrogen conformation. If any organic compounds contain nitrogen, how it will be conformed? Nitrogen means carbon, nitrogen and hydrogen, you can say cyanide or carbon, sodium cyanide, carbon cyanide. So if it is in the organic compound forms, then you can say that the sodium cyanide and cyanide, when the cyanide reacts with sodium, it will give you the sodium cyanide. Means if the organic compound which is containing nitrogen, it will give you the sodium cyanide, because sodium is highly electropositive elements, because ionization enthalpy is high, and this was given by Lesson's extract. It can be reacted with the ferrous sulfates. Sodium hydroxide will be boiled and cooled. It will give you the ferric chloride, and it will give you a green color solution. Here, as the carbon dioxide will get, it will give you a milky colored lime water, milk limes color solutions. In the second one, crystallization, copper sulfate solutions, blue color solution for the hydrogen, nitrogen for the nitrogen, Persian blue color solution. Especially it will give you hexacyanoferrate 2 ion or ferroso. Here there will be ferroso hexacyanoferrate 2 ion or pentacyanoferrate 2 ion, that will give you a Persian blue color. In the sulfur, if you react sodium with sulfur, it will give you sodium sulfide, and the sodium sulfide will give you a violet color. When this will be reacted with the acids, it will give you a black color precipitate. Sodium nitroprusside, that is Na2FeCN5NO, that is called sodium nitroprusside, and it will give you a deep violet color, that will be the presence and conformation of sulfur. Halogens, it will give you there are 3 types of halogens like fluorine, chlorine, bromine, and iodine, 4 types. So if there is chlorine present, it will give you a white precipitate. Yellow precipitate will conform with the bromine, and yellow precipitate will also conform as the iodine. Sodium halides will react with silver nitrate. It will give you the AgX precipitations, that is the white precipitations of AgX. Like silver chloride will give you a white precipitation, and when they will be mixing, that will give you a soluble separations. Last one, nitrogen and sulfur together, it will give you a black color, bloody red color, that is ferrous thiocyanide chloride ion. That will give you a bloody red color solution conformations. And the last but not the least, phosphorus will give you yellow color precipitations conformation. So by this, the qualitative analysis can be done. As what we have seen here, the conformations of carbon, the conformations of nitrogen, conformation of sulfur, conformations of halogen, conformations of nitrogen and sulfur, and conformations of phosphorus. Now the next one, that is called the purification of quantitative methods. Quantitative methods for understanding what amount of carbon is involved. So here, as I write the reactions, don't forget to understand the percentage of elements. Here you have to understand percentage of carbon and percentage of hydrogen. How you will calculate the percentage of carbon that are present in any organic compounds. So here the mass of carbon dioxide produced will be given, mass of compound will be given. You have to just calculate. As for just suppose in any carbonic compound there will be carbon dioxide form. So 12 by 24 into that given mass of carbon dioxide upon given mass of compound into 100. So this will be the percentage of carbon. If we talk about the hydrogen, 2 by 18 into given mass of water upon given mass of organic compound into 100, right? So this will be the value of percentage of hydrogen. Got it, everyone? Now we are moving towards the next topic, that is the percentage of nitrogen. How you will calculate the percentage of nitrogen? There are two methods. Percentage of calculating of nitrogen. Percentage of nitrogen will be calculated as Dummer's method and Kjeldahl's method. In the Dummer's method, we are going to calculate by the STP, standard temperature pressure, 28 by 22,400. Volume of nitrogen at STP by given mass of compound into 100. So this is the method called Dummer's method. Is it visible to everyone? Hope it is visible. And in the Kjeldahl's reactions, what you have to do, percentage of nitrogen will be calculated as 1.4 into molarity of acid into volume of acid used into basicity upon mass of the compound taken. Means the two types of methods for calculating nitrogen is, one is Dummer's method, this is Dummer's method, and second one which I am writing, that is called Kjeldahl's method. Kjeldahl's method, that is 1.4 into molarity of acids into volume of acid used, volume of acids into basicity upon, what will be the upon? That here, as we are writing given mass of compound, similarly we are going to write the mass of the compound taken. What will we write? Mass of the compound taken. Okay, so this was the quantitative analysis of organic compounds of nitrogen. Now we are moving towards the halogens. It is known as Carriers method. Carriers has given two methods to detect halogens and sulfur. If you are just doing the reactions of halogens with the nitric acid and silver nitrate, it will give you the silver chloride. So here, whatever this compound you are going to get means percentage of halogen. If you are going to calculate percentage of halogen, means X is equal to whatever the X is given, X upon 108 plus X. In the form of X, here you can write that fluorine, chlorine, bromine, iodine. Any X means halogens, means any of the four: fluorine, chlorine, bromine, iodine. This X into atomic mass. This X means this fluorine, chlorine atomic mass. Okay, and here also atomic mass into the volume of silver halide HEX upon mass of the compound into 100. So this will give you the formula of the percentage of halogens, how to detect the percentage of halogens. Very nice. Atomic mass of halogen, mass of the AgX form. Here you can write, well, not volume, here you have to write the mass of AgX, sorry. Okay. Similarly, if you want to calculate the percentage of sulfur, it was also given by the Curie's method. In the sulfur, you will get a compound called barium sulfate. Barium sulfate. What do you get? Barium sulfate. So here, mass of sulfur upon barium sulfate, mass of sulfur is 32 upon. What will be the mass of barium sulfate? Can you tell me? Anyone? 232, right? 233, not 232. 233. The mass of barium sulfate 233 into mass of barium sulfate given BaSO4 upon mass of the compound into 100. Mass of the compound into 100. Right? So to detect here about the sulfur, as you can see here, you can go through this method. Now let's come here. After sulfur, if you are going to get again ignition method, by the ignition method you can calculate the phosphorus. In the phosphorus you will get Mg3P2O7, that is also known as magnesium pyrophosphate. Here if you want to detect the percentage of phosphorus, how you will detect the percentage of phosphorus? Can anybody tell me? That is through the magnesium pyrophosphate, 62 upon 222, 62 upon 222 into the mass of that magnesium pyrophosphate, that is called Mg2P2O7. Mg2P2O7, mass of Mg2P2O7 formed upon mass of the compound into 100. Right? So this is the value of percentage of phosphorus. Right? And the last but not the least, that is called the percentage of organic. There are also by the two methods, one by the iodine and another by the oxygen. In the oxygen method, carbon dioxide will be formed. So the percentage of oxygen will be through the two method, that is 32 by, here carbon dioxide, mass of carbon dioxide will be formed, right? So here we will take 88, 32 by 88 into mass of CO2 formed upon mass of compound into 100. And the last but not the least, percentage of oxygen. Here we are going to take iodine 1 reaction, right? So here 5 into 16 upon 2 into 127. 5 into 16, because 5 atoms of oxygen will be there, upon iodine atomic mass is 127. 2 atoms will be of iodine. So 2 into 127, mass of iodine formed upon mass of compound into 100. So what you have seen here, you can go through this. Mass of iodine formed by mass of the compound taken into 100. Here mass of the compound taken. Here these are specially used for calculating the volumetric analysis. So this was the brief descriptions of chapter number 12, organic chemistry. Hope all of you have enjoyed. If you have gone through this, by this you can solve any numericals, any concept of organic chemistry. That's all for today. Thank you very much. Don't forget to hit the like button and subscribe the channel. Share this video with your friends so they can also benefit. Thank you very much.